Alright, so we're looking at some of your homework problems from your section 10.3, and in this section we learn about compound interest. So the formula that we need for compound interest is A equals P times 1 plus R over N raised to the NT. Now the parts of the formula: A is the future value, what your money grows to or accumulated, so the total amount accumulated is A. P is the principal or the present value that it starts out as, the principal invested or the amount loaned for. That's just the number 1. R is the rate, always change to a decimal. N, that we use in both of these places, is how many times the money is compounded per year. In this problem it says semi-annually, so that's 2 times a year, so we'll put a 2 down here and a 2 up here, and then time is the total amount of years involved, so 3 years. And actually you can think of N times T as being the total compounding. It's compounded twice a year and for 3 years, so for total 6 compounding. So it's the total amount of compoundings. All right, so for our problem it says find the amount in the account, or A, when we invest $5,000 at 8%, 0.08. Annually is a 2, and then 2 times 3. Now if you're getting any of these wrong, it's usually based on how you're typing it in your calculator here. For the exponent, I find it easier just to go ahead and calculate that number, and it'll be easier when you input it to your calculator, I think. So that's my advice on that. If otherwise, you'll need to put a parenthesis around that exponent so your calculator knows both of those belong in the exponent position. Okay, then it's a matter of how you type it in. So I'm going to type it in as we go here. 5,000 parenthesis 1 plus 0.08 divided by 2, close my parenthesis, raised to the 6th power equals. And I get to the nearest penny 6326.595, which is going to round up to 60 cents. So that's what I put in the first blank, 6326.60. And then the interest earned, you know, this is the total amount accumulated. It includes the 5,000 plus the interest. So we subtract back off the 5,000 to see that the $1,326.60 was the growth amount, or the interest that we earned. All right, and that's kind of basically what we do in this section. A lot of that, manipulating that equation. All right, another example, number 2. Same thing, find the total amount accumulated. So we're looking for A. A equals $3,500, 2%, so 0.02. Quarterly means 4 times a year, so we use 4 there and 4 here, and for a total of 2 years. So 4 quarterly, and then for 2 years, or in other words, 8 times this money is rolled over or compounding. So I'm going to type that in my calculator. 3,500 times 1 plus 0.02 divided by quarterly 4 raised to the 8th equals 3642.47 to the nearest penny, since the 4 after the 7 won't round us up. All right, so that's what I put in the first blank. And then the amount of interest, we've got to take back off the 3,500. We didn't gain so much this time, did we? 3,500. We still grew by, what, $142.47. Alrighty. Looks like we get to do that again in number 3, similar. It's monthly this time, so getting a little practice with the different compoundings, you know, semi-annually, then quarterly, so monthly before we leave this. So practicing again, A equals P, 1 plus R over N to the NT. So we got $7,500. 6.5 will be 0.065 divided by monthly. That means 12 times a year. And it did say for 5 years, so times 5. So I recommend just timesing that and getting that number first. That way you won't have any issues with your calculator and parentheses and all that needed. If you were going to type it in straightforward and forgot to multiply that first or something, let me show you what I would do on my calculator though, just so we'll talk about that. So when you raise it up to, you need to say the 12 times 5 power like that. You need to tell your calculator that you need 12 times 5 calculated separately and as the exponent. So that's how you'd need to type it in otherwise. Or just say to the 60th, I still think is the safest thing to do. This is one of my most common questions I get, emails or student questions, is about typing this into the calculator. So I think to avoid it, it's almost always due to that exponent. So multiply that first, know it's 60, raise it to the 60th, and you'll have no problems. I think that'll fix it. So here's our answer, $10,371.13. The interest earned, we always have to subtract back off our principal that we started with, which was $7,500, to tell how much of that was growth amount. So I subtract off $7,500 here, and quite a bit there in the 5 years. $2,871 and 13 cents of it was interest growth. All right, let's see if we continue on here. Yep, same thing on number 4. So I think I'll skip over 4 for now and move on to number 5, something different. On number 5, it says use the present value formula to determine how much to invest now. So we're going to work it a little bit differently. We need to know the present value. We don't know P, so we'll be leaving P out of the formula, and we know what A is. We know that we want to get to $40,000, so that's actually the A value on this side of the equation equals P. We don't know P. We're looking for P here. It says 6.3%, so that's 0.063. It does tell us monthly, so that's a 12. And then how many years? 11 years. So pretty long. So if we want to have $40,000 in 11 years at this percent compounded monthly, how much would we need to invest? Now, I always recommend you multiply 12 times 11. Just have that done. And that's the 132nd power. So what we're going to need to do is do all of this on our calculator, and then it will be P times that. So we know from our algebra that we divide to solve. So we'll have 40,000 divided by whatever all this stuff is. So I'm going to type that in my calculator. Parenthesis 1 plus 0.063 divided by 12, close your parenthesis, raised to the 132nd power. And that equals some awful long decimal, 1.99608, da 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 da. So you want to keep as many of those places as possible, but the ultimate way to do this is then say 40,000 divided by, and pull up your last answer. Now, not every calculator has that ANS button, but a lot of calculators do. Mine is over the subtract or the negative sign. And so that's where it's at in a lot of calculators. Not every calculator has it. Some calculators have a store feature, and you can store answers there and say recall, store and recall. That's a possibility. But if not, then just transcribe that number and type in all those decimal places to keep it accurate. All right, so that comes out to be 20,000, almost half of it, right? It's almost going to be half money, and it doubles in the 11 years. So if you could invest 20,000 and some dollars, what is that in 24 cents? $20,039.24 in the bank today, in 12 years or in 11 years compounded monthly at this percentage rate, your money almost doubles. It gets to $40,000. So that's kind of working the problem in reverse to see what you need to start with now. Let's see, I think we're going to do the same thing on number 6. Use the present value formula to determine the amount to invest now. So we're desiring 85,000. We want more this time. 85,000 in 11 years, and a smaller interest rate though. We're compounding it less often too, so it's going to take more than on the last one. We'll see on this one. But anyway, the formula will crunch that out for us. We know the A value is 85,000. Equals the P value we are looking for. It's 3%, so that's 0.03, and it's compounded semi-annually, so that means use a 2 for N, and we're going to leave it there for 11 years. Now, I always recommend that you go ahead and times those two together, so let's call that 22. So we're going to figure out what this number is, and then it's going to be 85,000 because we have to divide that to solve. You know, that's multiplied. So whatever we get here, you divide it on this side to cancel it. So you divide it under this side. So it's 85,000 divided by all of this calculation. So let's check our calculator. 1 plus 0.03 divided by 2, close your parenthesis, raised to the 22nd power. That equals 1.3875, yada, yada, yada. So we want to divide that to each side. Either write that number down somewhere with all the decimal points that you see there to keep it accurate. And then it'll be 85,000 divided by, you can either put in those numbers, or if you have the A&S button, do that. So that tells me I would have to start out with $61,258, and that'd be 45 cents today to get my money to grow to 85,000 at 3%. 3% is not near as good of a rate, right? So that's going to be a thing. And also is only compounded twice a year semi-annually, so that's also a factor. Doesn't do as well that way. All right, but it still grew, right? Okay, number 7. Let's see, what are we doing here? Marcus receives an inheritance of $4,000. He invests this money in a 19-year CD that pays 5% compounded monthly. How much will he receive at the end of 19 years? So that is an A equals. Back to straightforward with it. We're looking for A. We have started with inheriting the $4,000 and investing that as our p-value. So we don't know A on this one. We're looking for A. And the rate is 5%, so 0.05. It's compounded monthly, so that's 12. And we're leaving there for 19 years, a long time. So 12 times 19, let's go ahead and call that 228. So all of that I'm going to type directly on my calculator. So it will be 4,000 times 1 plus 0.05 divided by 12. Close your parenthesis, raised to the 228. And that 4,000 will grow to $10,322, and to the nearest penny, 45 cents on that. Number 7, I'm going to double check. I have the answer key, so I should check my answers, make sure that these are accurate. I could make a mistake, hey guys, and if I do, please have mercy on me and send me an email so I know to refresh my video and fix it. You know, so that could happen. All right, number 8, I think I can do one more of these before my video time runs out. Let's see, Karen is investing $15,000 at an interest rate that's semi-annually, 3 years. She withdrew the full amount towards the down payment. So it's pretty much the same problem. These are just more wordy problems, I guess, is the new change up is they're asking us to kind of analyze in a real life situation. But it's still same old here. We got $15,000. The rate is given 1.75, so it's 0.0175 as a decimal. Semi-annually means put a 2 there. And she, how many years? 3 years. 3 years later is in the word. So 2 times 3, go ahead and call that 6. You know how I feel about that. And then type it in. 15,000 times 1 plus 0.0175 divided by 2, raised to the 6th. And there we go. It grew to $15,804.93. So not a super amount of growth there because the interest rate was very low. Again, checking my answer. I should do that more often. Okay, let's see. There's 2 more to go. Do we have time to do these before my video runs out? I don't think so. So I'm going to go ahead and pause the video here, and I'll do the last 2 on the next segment.